Okay, so welcome to the video that I promised you. Okay, so what we're looking at here is we're going to actually have a look at this program called Space Engine. Okay, it's available on Steam. All right, I know what you're going to say, probably it's a video game, what have you. But anyway, the planetary in the solar system here is extremely accurate. You can actually predict eclipses, comets, everything that we can actually predict of celestial objects, you can predict with this engine because it fits the model that is exactly what we've been using for a long time to actually predict future events. Okay, well, let's look at it. Okay, so here we see the moon. Okay, this is obviously the illuminated side of the moon, and if we rotate around, we can see it shifts from light to dark as we have parallel sun rays illuminating one half of the moon. Okay, this is apparent because here's the sun. Okay, and as you can see, the moon is facing the sun. And if we look exactly on the dark side of the moon, we can see that the sun sits right here in the middle. We can look up, see where the light starts to shadow of the surface of the moon in all directions. You can see it, right? Because the sun is illuminating the moon. Okay, now we see the Earth down here in the background, okay, with a very similar pattern of sunlight on it. Okay, so let's go ahead and jump over to it, and we can see what is happening here. Okay, same thing. We have a round planet with half of it daytime and half of it nighttime, with the same premise as the sun being in the middle of the object that it is illuminating. Okay, now I want to point out the time of day I have here. Okay, so this is today, June 21st, 2021, 000. Okay, this is UTC, this is GMT, Zulu time, whatever you want to call it. It is 5 hours ahead of Central Time. Okay, so that would make this 7 p.m. Okay, you can verify that if you don't trust that math, but it is 5 hours ahead. Okay, so let's look at Chicago, where you said you were when you took this video. Okay, a little upside down here, so let's turn it right side up. Okay, just so what we're used to seeing, United States here. Okay, I'm guessing that Chicago is probably somewhere around here or so. I believe that's Indiana, Lake Michigan, so I believe Chicago is somewhere around here, right? So we can actually go and let's try and get this centered up as much as possible so we can land on this object. So we're going to land right around there. Okay, and let's look around and find some objects. Okay, so there's the moon. Okay, there's the sun. Okay, look, this looks very similar to your video here of what you saw. The moon and the sun, the positioning in the sky. Okay, time hasn't changed, date hasn't changed. We're locked in time here. Okay, so now let's zoom into to the moon here. Okay. And I'm actually going to put a side-by-side comparison of what you saw in your video to what we see here. Okay, and we can compare them. Okay, so while I was editing this video, I actually wanted to do something a little extra than just put a side-by-side comparison. Okay, so I'm in this editing software here, and I wanted to actually do something interesting here. I wanted to put this over and show you exactly how close this moon image is to what we're actually seeing in your video. It is uncanny on how accurate that actually is. And see how very similar it is. Okay, and nothing's changed, right? All we did was just land on the surface of the Earth, and now we can actually see what the sky looks like. Okay, but the positions of the planets haven't changed. Nothing has been redrawn or reanimated. Everything's still exactly where it was. And this is extremely accurate of how reality actually is. Okay, so let's go ahead and jump back to the moon just so you can see that nothing has actually changed. Boom, right? We just jumped right off the face of the Earth, went to the moon. Nothing changed, nothing redrew. It is exactly how it looked on Earth at this position right here. Okay, and as we rotate back around, we see that the sun is in that position and that the Earth is still in its position. Okay, all of this checks out with exactly what we predict this looks like. With our current model of our solar system, there's no flat Earth program like this that will be able to demonstrate and predict any of this, any of it whatsoever. Okay? If you want to reply, comment, or whatever on this video, hit me back up on Facebook. You can also leave a comment here on YouTube. I'm going to upload this to YouTube, so you'll be able to see this. So I hope you actually enjoyed this video, and I hope that this actually shows you that it is absolutely possible to see what you saw in the sky using our current globe model that everyone has come to accept as the most accurate and most predictable.